Hey guys, Luke with S&S Diesel Motorsport. So we got a lot of interest, a lot of excitement with the DCR Ford 6.7 liter power stroke conversion. We unveiled it at the National Farm Machinery Show a few weeks ago, and wanted to answer some questions that have been coming up and give you an update on where we're at with it. Some of that is, when is it going to be available? What kind of validation testing has it gone through? Why is it needed? Where is it made? How does it compare to some competitors? And can it make more power? Does it have more output? So first, for timing wise, we've been doing a lot of validation with this thing the last year and a half. Lots of testing, lots of engineering design, lots of durability testing. And we're ramping up production now, packaging design, all those kind of things. So it's looking like June this year is when we're going to be starting to fill those orders. We got a lot of pre-orders already from dealers and customers. Thanks for those, and a lot of excitement. And we're going to be getting this out to you as soon as we can, but we're going to do it right. We're not going to cut corners. We're making sure that it's as flawless as possible, so they're off and running and no issues whatsoever. So we've done some other videos that tells a little bit more about the history of it. I don't want to go into too much of it now and make the video too long, as far as why this is better, why this is needed. The CP4 that is in the 2011 to current Fords has earned a reputation of failures, and you look at some of those other videos for some more details on that, but it's a really painful, expensive failure. So this is the solution for that goes in, prevents downtime, prevents a lot of money spent on parts that you shouldn't have to buy. So this is has been a huge disruptor and huge news for the 6.7 Ford market. With that being said, there's a lot of companies that have made a lot of money the last several years selling CP4s, and obviously they're not going to be happy about this, because there's not going to be no reason to buy a CP4 from those anymore after this comes out. So keep that in mind with any kind of information that you're hearing is based on where it comes from. Obviously, you could say it about this as well, but honestly, as cheesy as it sounds, our goal really is to develop the best possible products that we can, educate the customers and dealers about their vehicles, their engines, their fuel systems, and really let them decide what's the right fit for them. We like to get feedback from the field as to what kind of failures they're having, where they need better products, and those kind of things, and then that's where we focus our development and our resources in general. So another question we commonly get is, where is this produced? So there's a lot of different components that come into this kit. Some of them are coming from US manufacturers, some are from France, some are from other parts of the world. The base pump itself is manufactured in China. And the reason for that is because this is originally an OE pump. It's a Standardine design. It's been in production since 2014 with over 700,000 of them in the field. We are bringing it to the aftermarket for the first time. It was always designed and developed for a OE application, and those are actually much larger engines than what the 6.7 Ford is, but heavy-duty engines from major manufacturers that I'm sure you'd be familiar with. But those engines and those trucks that this was originally designed for are in Europe, India, and China. And so since though a lot of that demand was from over there, manufacturing plant was built in China to build this pump. Modern state-of-the-art manufacturing plant like the one that makes the iPhone that you're probably watching this video on. So with that being said, since we are bringing it to the US market, there's actually a plant being spooled up in the US right now, which will be producing this in the future. And we have high confidence in this design, in this manufacturing. It's a very high quality product, and it's always been designed and validated in the US. US companies just manufactured for other regions and different parts of the world. So there's a big difference between cheap Chinese knockoffs of products of other companies and high quality Chinese manufacturing that is done intentionally. So we get, and us ourselves have had a lot of negative impacts from Chinese knockoffs of some of our kits, for example. Stuff that we designed, some other companies trying to do a cheap version to compete with us. They're low quality, they have problems, lots of those type of things. There's a big difference between that and US companies with their own manufacturing plants in different parts of the world. For example, these Bosch pumps, CP3, CP4, This is world-class manufacturing. This is done in the Czech Republic. The new versions of these pumps both come from the Czech Republic. Like I say, very high quality, state-of-the-art manufacturing. The base design is a lot different, but from a manufacturing perspective, it's top-notch. And the remans of these is hard telling. Some aftermarket companies are using a reman CP4 based body. It's hard telling where those come from or what is done to those. What we've seen of them here recently is pretty surprisingly poor, but the new versions at least are actually from the Czech Republic. So next popular question we get is validation testing. Why are we confident in this? Why is it going to be better? Overall, and we've explained this in some of the other videos, the base design is so much different and so much more robust that it's kind of night and day different, really. This is a really high speed metal-to-metal interface that in 11 to 19 anyways can rotate 90 degrees like that and cause damage. Some of our other videos we went into a lot more detail in that. This is a roller on a bushing, pressure lubricated through the cam, so it's actually floating on pressurized fuel lubrication here. It's in general much less sensitive to debris, low lubricity fuels, anything like that. So validation wise, this base pump had gone through many durability tests, abusive testing, all that before anybody would have ever approved it several years ago for these heavy duty engines. Even though the base pumping elements is very proven and validated, for the specific variant that we've developed for the Ford, we're going through and doing a lot more of that validation testing itself. So that includes lots of bench testing of various pumps at high RPM, high pressures, lots of kind of accelerated abusive testing, as well as low lubricity testing. Done a lot of testing with JP8, for example, which is a military fuel that's low lubricity. Much worse than regular number 2, even the US diesel versus European diesel or whatever, that gets thrown around a lot. JP8's a lot higher wear scar and lower lubricity. So the DCR really shines with a lot of that because of some of the base design features. It's even better than the CP3, which is a really good pump, better than the Denso HP4 by a long shot. And a lot of that is literally because of the reduction of moving parts, not metal to metal sliding and high speed friction, and the pressure lubricated cam. So by design, it's just far superior and less sensitive to any of that kind of fuel quality problems or overspeed issues or anything like that that can cause some of those failures. So in addition to lots of bench testing years ago for the base, as well as now with the complete package and lots of abuse, we're doing a lot of field testing also. So by the time we release this, we'll have had it in the field for over a year in various applications. So that's almost all model years. That is F250, 350, 450, 650, all the different ranges, cabin chassis, pickup, ambulances, all the way up into Canada to get cold weather testing, South Texas to get hot weather testing, heavy towing, lots of idle time. Ambulances, for example, get not a lot of miles, but tons and tons of idle time. So we thought through all this in a very methodical manner, and that's something that honestly is unique to the aftermarket. So our strengths is we come from OE engineering backgrounds, and we take that into the aftermarket. We can take the best of both worlds. So we come up with, all right, we want to validate all these different scenarios and try to put this thing through every bit of abuse testing so we know that we've got the utmost confidence in it. That way you can have the utmost confidence in it. So that's really been the goal here. And we've had great results with all of our field testing of the fleet of trucks that we've got out there. So the validation testing part of this has been so important to us to make sure we do it right that we've actually developed a data logger, worked with some really smart electronics guys, and developed our own data loggers as well to be able to use in these trucks. And so we've got data loggers plugged into the OBD, got SD cards, and they're collecting lots and lots of data at high rates of speed. That way we can pull that data, analyze it all, and really make sure that the product's working as flawless as it is. This by design is a drop-in, no tuning required. All the pump modifications and everything that we've done to this pump to make sure that it works right is so that you don't have to do anything else. You put hardware on only. So we've got hundreds of thousands of data points to really validate that every detail and every bit of the truck, rail pressure control, power, emissions, everything like that is running exactly as it's supposed to. Also, we get asked regularly, how does this compare to other alternatives on the market, other competitors? As I mentioned, the base architecture is much different. So anything that's the CP4 based is going to be susceptible to a lot of the same failures due to the sensitivity of the base design. We've been begged for years by our dealers and by customers to do CP4 pumps, stroker CP4s, all that kind of thing. We could have made a pile of money selling those because they're easy to do. But we knew what the risks were with that, and we didn't want to put our name on something that we didn't have the utmost confidence in. So you shouldn't have to sell a product that has a built-in disaster prevention kit or system saver if you really had product or confidence in it. So that's why even guys, we've got that question a lot too, they already have our Gen 2.1 disaster prevention kit on their truck and they ask, can I use that with this pump? One, it's not compatible because of a few details, but two, it's not even necessary. So you get rid of it, you put one of these on, you don't have any concerns about reliability, unscheduled downtime, extra cost, any of that kind of thing. So from a base architecture, it's much, much different. And we haven't wanted to start with this and try to make it better. Polish a turd, some would say. So there are some alternatives out there that have a built-in DPK similar to, that's an S&S design, but similar to something that we did years ago. This is our original first gen that we actually redesigned to make it easier to install as well as much better protection. So one thing that we did was we want to split the flow of the bottom end of the pump. So fuel comes into the pump, into the bottom end, up to the metering unit, and then to your high pressure heads and injectors. So what we did with the first gen is we had a block off where this actually, I don't know how well you can see in the camera, fuel came into here, it fed down into the case, but it also fed the FCA or the metering unit directly. One reason we redesigned this, because in certain cases, you can actually get the pump puking back upstream or trying to, because what happens, that you only know this if you actually do a lot of testing and destructive testing, is the pressure regulating valve that throttles the amount of flow and the pressure in here that goes back out through the return has a screen on it. So when these fail, it actually plugs that screen and pretty well deadheads flow coming in and out of the pump for cooling and lubrication. So it's also not carrying a lot of it's carrying some debris because that screen's not really fine, but it's not carrying a lot of flow anymore. It basically kind of blocks a lot of that. So what happens is you have a lot of turbulent motion in here, and then you just have metal that's getting churned in here, and there's not much separation between where you're pulling off that to feed your FCA or metering unit. So an additional advantage that we did in our redesign was getting this separation way, way far away. So some of the alternatives that claim you don't need RDPK or this DCR anymore actually block this factory feed, but do an angle drilling into here. And what you end up with is basically that much separation between the cam box and the feed to the FCA. So we had about that much in our Gen 1, and sometimes it would do well. We've actually got a lot of reports of it doing okay, but we knew in some situations that depending on how long the pump was dying, how it was failing, all those kind of things, it's not going to be as guaranteed as our Gen 2 or 2.1. Well, now with this other alternative, you basically have that much separation between all the metal filings that this thing's generating and when you're pulling back up and off and feeding this FCA. So other question is guided buckets versus not on the CP4. So 11 to 19 Fords, didn't have anything to keep the buckets from rotating like this. The pumps run often in a vacuum. They're inlet metered, so they often, actually all the time, are partially full. They're almost never actually running at full capacity. So they're throttled on the inlet so that they don't waste a bunch of energy and pumping power. There is never really a situation, even though it could be communicated or perceived in the market, that there is a vacuum happening that actually like sucks this thing off of the cam. There's never slop or a gap here, except for maybe in really high speed situations where it's like floating the valves in an engine that doesn't have enough cam spring pressure. So these things get assembled with a lot of spring pressure pushing down on this. So even when it is a partial vacuum on the plunger, that's almost no functional force vacuum. So the spring pressure, there's an excessive amount of spring pressure that holds this thing down on here. There is some situations where they can still turn, and we do see that quite a bit. So theoretically, pinning that bucket should help. But what we've seen, Ford did that in 2020. There's still failures after 2020. The best example of that is in 2019, Cummins launched the CP4 for the new 2019 engine, started having a lot of failures. They switched running change to a newer reliability package, which was basically a clone of the 2020 Ford, had a larger diameter roller that was attempted to spread that kind of point load contact out wider, and also had a pinned bucket to try to keep that rotation from happening. There was as many or more failures of that new design on the Cummins application than there was the original. So that goes to show that that's not the magic fix for that also. You still can and will have failures of that. And then Cummins stopped production of that, switched back to the CP3, and then has recalled the CP4s that are out there. Even, I mean, the CP4s that are out there with pinned buckets are under recall right now. So if that tells you anything. Some of why we know that is because we have OE, we do quite a bit of engineering consulting for OEs, and we were consulting with OEs on CP4s and why they're failing, and instrumenting pumps and doing a lot of testing and helping them to really determine all the details as to why they fail, what situations cause that, what happens when they fail, things like that. So our expertise is fuel systems. We're not trying to do a bunch of other engine parts, transmissions, a lot of that kind of thing. So we try to focus on fuel systems and do the best possible job of that we can. So another question we get, or misconception, is related to pulsations in the rail and a 2-cylinder pump versus a 3-cylinder pump versus a 2-cylinder pump that actually strokes twice per revolution. And the best way to explain that is we'll go to the engine and show you what it looks like on the engine. So we're here at our display engine with the DCR high pressure pump conversion installed. We'll follow the fuel path real quick. So this is coming from the tank, from your electric supply pump into your second stage filter. Our kit clicks straight onto here like factory with a quick connect, delivers fuel to the DCR. There is a mechanical pressure regulator built into here that controls low side system pressure and cooling and lube flow through the pump. Any extra comes back through the return, ties into your regular quick connect on the rail, and goes back to the tank just like factory setup. High pressure outlets then, the IMV throttles the amount of fuel into the pump on the high pressure side. The high pressure outlets are on the back here. Custom high pressure lines come with this kit. They come over here through clamps, just like the factory setup, and they come over here to exactly where the CP4 factory high pressure connection points are. Then there is another high pressure line that crosses over to the passenger side rail. They have to get balanced and isolated both sides. These rails are just accumulators. They're just pressure tanks basically. So they are just holding pressure in the system until the injectors inject whenever they're told by the ECU. So this crossover line, there's always going to be one on any V8 where you've got two different rails. You have to have a balance line to pressure balance between the two and deliver fuel to the passenger side. Like I say, it's pretty much the exact same setup as the factory. And then you have a high pressure line coming off of the accumulator, off of the rail to feed each injector. And then we'll talk a little more about how the rail is designed in detail. So as you saw in the engine, there's 2 high pressure outlets on this pump, just like there's 2 high pressure outlets on the CP4. They come into the front of the rail. There's a crossover line that goes rail to rail. What the OEs did a really good job with, and very intentionally, there are very small orifices in these rails. Those are designed to isolate pressure pulsations from cylinder to cylinder, as well as from the pump to the engine to the injectors. And there's even little isolation throttles and orifices in the rail itself between the pump and the injectors. So by design, the system does a good job of isolating pressure pulsations from all the other cylinders, because when one injector fires, you're basically opening a valve, and so you're going to get a little drop in pressure. When another one fires, you're going to get the same thing. When the pump is pumping into the system, you're going to, if you log it, which we have at very high rates of speed, you're constantly getting pressure waves in the system. When a lot of original development of the CP4 was done, and this is because we have experience in those scenarios, and my business partner Andrew was at Bosch when LML was being developed, emissions testing was done timing the pump to all kinds of different various locations to get some of the pump inlet and injector outlet pressure waves to line up differently. The conclusion was basically that it was within measurement error on any of the emissions testing. So they decided to time it anyways, but from a functional perspective, it was marginal that any of it needed done. There's only 2 reasons to time a pump. One is to try to get pressure waves to line up or not. Like I say, by design, there's a lot of isolation into the system to make those pressure waves get dampened out. And also, another reason would be to get the harmonics between the pump torque and the engine torque to line up at really light load, because of the amount of torque that the pump is drawing basically as it is pumping, as well as when the crank is accelerating as certain cylinders are firing, because the crank's not just spinning smoothly, even though it looks like it is, seems like it should. It's actually accelerating and decelerating as certain cylinders are firing. And so depending on the timing of that, sometimes you can get a little bit of gear chatter at light load. So that is one of the other reasons that you might time it. And we're studying that actually currently with the DCR, trying to make sure that in all scenarios, really light load stuff, different model years, is there any time where we get a little bit more gear noise or not from a reliability or failure perspective, but purely from a acoustic perspective. So there's really not much from a 2-cylinder, 2 pump per rev, 4 pump per rev, 3 pump per rev. If there was issues with that, a 3-cylinder pump like the CP3 that has 3 pulsations per revolution on a V8 like the LB7, LLY, LBZ, LMM would have had problems. A 3-cylinder on a 6-cylinder engine like the Cummins that's not timed at all. The Duramaxes, they had a CP3, aren't timed at all. We're using lots and lots of CP3s and LML, CP4 conversions. That is a CP3 3-cylinder that's not timed. There's lots and lots of examples of that being the case. So it's not like the pump is delivering fuel to a particular injector. We'll do another video that's Common Rail 101 that really explains like how the system works, but the pump is literally just supplying fuel to an accumulator. This is just a tank that the injectors pull out of. So all it has to do is provide pressure into the accumulator. After that, the injectors decide when to fire. They're all electronically controlled. They just have pressure fed to them and they decide when to fire. The pump is not producing the actual injection event. It's happening downstream as the injector fires. The only job that the pump has is maintain pressure in the rail in the accumulator. So on that topic, the pump itself doesn't have anything to do with actually injecting fuel. The pump's job is purely maintain the pressure that the ECU is commanding for it to maintain in the rail. Lots of very detailed changes to this pump is what it takes for that to happen correctly so that you don't end up with rail pressure surging and things like that. So one other question we get is, will this pump make more power? Because this pump is higher output than the CP4, or it's a higher displacement. It's roughly 25% higher displacement than the CP4. That means it is capable of more fuel, but the pump does not produce power itself. The injectors are what actually delivers the fuel. So this pump has been designed specifically to match the stock output of it. We do have a couple customers who are actually using this in drag racing applications. In those cases, when it's not in the stock form and you ask for the pump to actually deliver more fuel, it can, but it's been very specifically designed for all the stock truck applications to just deliver the amount of fuel that the ECU is requesting in stock form. So that's a somewhat misconception that we run into sometimes. Like I say, the ECU and the injectors are what controls how much power the engine makes, and that's what's delivering the fuel. The pump's job, purely create flow, to create pressure, to do exactly what it's told to do by the ECU. So the summary of this, probably long, standard Luke 2 rambly video, is this pump is the ultimate solution for the Ford application. We've done all the due diligence we possibly can to make this the best product it can be. By design, it's far superior than any other alternatives that are out there. And then we're doing, my team is doing much more validation and much more detailed analysis than anything else out there. I'd put money on that hands down to make sure that this is the best product for you. So if you got any other questions, feel free to ask, hit us up in the comments, and we'll have some more content coming soon also, but we appreciate the support. Thanks.